let's back up. Let's back up. This is back to the lowered lung function. So we were assuming that secondhand smoke has no lower, oh, I got it right that time, has no lowering effect on lung function from 0 to 1 hour. So we're going in assuming it's got absolutely no lowering effect, and then holy crap, it lowered the lung function. We were expecting it not to, but it did. What do they call that? Oh, good! Good for you. It's an outlier. It's a contradiction. It's an outlier. It's a disagreement. It's a butting of heads. So we write the article. Secondhand smoke lowers lung function. I have one question for you. Could we be wrong? There should be something popping up. There it is. Yes, it appears to be. There we go. Could we be wrong?
Yes.
How? How could we be wrong?
Variables testing variables, something could have
Good. So, in other words, it could be that we came out of the article and said secondhand smoke lowers lung function, but in fact, it doesn't. What did we just do?
False positive?
We just made a false positive error. Why is it a false positive? It seems kind of weird to call it a false positive error. Why would we call it a false positive for?
Because you were finding out if it lowered lung function, you got a positive, but you were actually wrong.
Hey, thank you, Allie. Thank you, Brandon. A positive test result means you've gone away from the null to some alternate explanation. That's a positive test result. When you go in to test for a disease, you don't go in assuming you have the disease. You assume you're clean. When the test comes back positive, then you're like, okay, this might be a false positive. But the positive test result means away from status quo. Away from status quo. Is that fair? You guys buying that? Good. So we could be wrong, definitely. How? Because it could be a false positive. Now back to this guy right here. How about after 3 hours? Okay, here's the analysis of that. We were assuming secondhand smoke has no lowering effect, got it right again, on lung function after 3 hours. Bigger than 5%. Why is it bigger than 5%? Why is it so big?
because it went back to what it is.
Because exactly, the lung function was non-lowered. We were expecting it to not have any lowering effect after 3 hours. It didn't have any lowering effect after 3 hours. It agrees. There's no contradiction. It's a huge probability. It's not an outlier anymore. So does it appear to affect? I think I did that right. It is to affect. That's the verb. Yes, okay, I got that right. Hot damn. Well, those dead nuns who taught me grammar in 8th grade are happy right now. Secondhand smoke appear to affect lung function after 3 hours? No, it appears to have no, well, I shouldn't say that. It might have a cumulative effect, of course, that we're not measuring in this study, but a short-term effect, no, doesn't appear to have any. Could we be wrong? Of course we could be. Look at the damn curve. Now, I don't think anybody doubts the location of this red curve right here. But suppose you landed here after 3 hours, right? 3 hours lands you here. Now, I drew the green curve on top of that because we usually observe average, right? We usually observe average. But what if the true green curve, which I'll make blue, is actually down here? And we just caught an outlier on it. Is that possible? Is it probable?
No.
No, especially not the curve way the hell down here. But if the curve was closer up here, would that be more likely to be on it if I move this bell? Yes, you see what happens, right? The closer I move this bell, the more likely it is to be on this curve. Of course, it's still more likely to be on the original curve. But then comes the dance of how close is close. We'll get to that next 5 weeks. So the question is, we could be wrong by saying that there is no effect. What do we call that? That would definitely be a false negative, wouldn't it? Wouldn't that be a false negative? Because you said secondhand smoke doesn't do a thing, but it might. And you missed it. Correct? Good. Which one is worse in this case? A false positive or a false negative? What do you think? False negative, false negative. Anybody else? Votes? Worse being, worse for, okay, define worse. So you guys said false negative almost immediately. Tell me, Allie, why?
Because if you say that it doesn't affect lung function and then you expose people to it and then find out it does decrease lung function.
I have this kind of, I think Allie may have the same, we're thinking of long-term health effects on the population. If a study is done that shows secondhand smoke doesn't have a deleterious effect on your lung function, go ahead, keep smoking. Remember back in the day, you guys might not because you're young, they had smoking sections in restaurants. As if the smoke would just stop
Yeah.
at that section, not going to the other section.
Exactly.
They've gotten rid of those because they realize smoke is dumb and it doesn't obey imaginary planes of existence. So that's what I was thinking about. Like, if a study like this comes out and says, you know what, it smokes fine regardless of the type of exposure, go back and smoke at restaurants again. Sure, it inconveniences people, but it doesn't make them sicker. That's why I think a false negative would be worse, in my opinion, too. A false positives are usually false negatives when they have serious consequences are avoided like the plague. For example, how many of you have ever had a car recalled for a safety recall? Seat belts, trailer hitch. Our 2005 Jeep Liberty diesel just got recalled for a trailer hitch and 2 other things. Now, everything was fine, but they pulled back for those 3 safety issues. Why?
Better safe than sorry.
Because of the Ford Pinto, better safe than sorry. Remember the Ford Pinto exploding gas tank debacle of the 70s? Do you remember this? They made fun of it in the movie Fight Club. Brad Pitt's character in Fight Club was talking about that. I'm an insurance adjuster for a company. What we do is we figure out the cost of a recall, and then we analyze what the insurance payouts would have to be for the victims of that if everything goes wrong. Say if the gas tanks explode. How much would we have to pay for those victims and the insurance policies? If that's less than the cost of a recall, don't do the recall. Now that sounds like the most evil corporate America greed. It actually happened with Ford in the 70s, with the Ford Pinto with exploding gas tanks. He's making fun of that. But that's where you don't want to go with a false negative. Oh, your gas tank's fine, keep driving on it. You want to avoid that like a plague, right? So you'd rather err on the side of more false positives. Fair? Does that make sense? That's where you actually lower the confidence of your test. 95% would be too high. Lower it to 80%, which creates lots of false positives. But it also reduces false negatives. By definition, it has to reduce false negatives. More on that mathematically as we go through the course. I promise you. I promise you. But yeah, so I'm with you guys on that one. Anybody think a false positive is worse in this one? You can totally think that. I'm not saying there's a right or a wrong. As a statistician, you have to decide which one you want to avoid and control for it. Cool? All right. A little bit longer in this one. Let's talk about ways to be wrong and then leave it for Thursday. Ways to be wrong. I want to analyze this. There's 2 ways to be right and there's 2 ways to be wrong, and I want to talk about all of them, starting today, and we'll finish it up on Thursday. Okay, you're on a test, you get a small p-value. You call mom? Do you call mom with a small p-value? Why do you call mom?
Something changed.
You were studying something, and you were expecting nothing to happen, and something happened that was exactly the opposite of what you quote-unquote were expecting. So something's changed. Something's changed. Ma. I've been studying the landscape of the Chute National Forest for years, and all of a sudden we've got a significantly larger percentage of cheatgrass than we did over the past 5 decades. Boom! Based on a sample of each other. You call mom, I'm gonna publish it, ma. Your mom goes, yes, dear. Could you be wrong? And you go, okay, mom, I guess I could be wrong. What's the chance that you're wrong? You know the answer to this. Elizabeth,
1 in 20.
it's 1 in 20. Assuming that you're working at what?
95.
Right. Now this is what I mentioned before. If the car companies very often have false positive recalls, they may have more than 1 in 20 false positives. They may have 4 in 20 or 5 in 20 or 6 in 20. They may have 10 in 20 because they're trying to reduce the Ford Pinto debacle. They don't want anything to happen because if that trailer hitch rips off and creates a spark, what else could happen? The fuel tank can blow up or the car can catch fire. That's what you don't want to have happen. You want to reduce that down to as close to 0 as you can have it. And the only way to do that, well, we'll get back into that too. So I want to talk about what we call false positives. I wish that all statisticians would just call things false positives because they do make sense. False positive in 244 in inferential stat is called a type 1 error. Why? I don't know. It just is. Why do we say reject the null? Because somebody did years ago. We're stuck with that language. It's got a symbol. Of course it does. It's called lowercase alpha. That's a little a in Greek. Lowercase alpha. Little a in Greek. Usually 5%. Unless you want to avoid a type 2 error. You make that bigger. Which means you have to lower confidence. This is inversely proportional. It's complementary to the confidence of your test. If this is set to be 5%, that means your confidence has to be the other 95. Your confidence has to be the other 95%. Is that fair? So 95 plus that has to be 100%. That's your null curve. That's your null curve. Believable? Cool, cool. We'll come back. And this goes back to Aaron's question from an hour ago about I keep seeing these 5%, these 0.05s in the research text because they're operating at 95%. I'm not saying it's always the best. I'm saying it's what is generally used. Fair enough? All right. Here, from the secondhand smoke article. At 0 to 1 hour, time of initial secondhand smoke exposure, most lung function parameters were significantly reduced. And they gave us the p-value to kind of drive that point home. We've got a p-value of less than 5%. So you swing over to that red curve and you go, okay, I see what those researchers found. I see what they found. They found a camera that can't stay up. Hang on. Those researchers assume that that red curve right there, not the blue one. Let's get rid of that blue one. It's getting confusing. I mean, hell, the blue one could be where the lung function parameters are. Could we be wrong? Of course. Because we landed in this 5% region. There's still a chance we're there. It's a small chance. It's less than 5%. But it could be on the nothing's wrong curve, nothing changed curve. It's just more likely somewhere else, at least according to our argument. So phrase it to your neighbor who now quoted to you, oh my God, did you hear on the news? I heard secondhand smoke. It makes your lungs like rot out. So the first thing you do is you correct them. You say, okay, let's define what rot out means. And then, yeah, but secondhand smoke is still bad for your lungs. And you come back with a number of arguments saying you've critiqued the study, and then you interpret what the p-value of 5% is for them. Do you say, well, they could have made a type 1 error? Or do you say what?
There's a 1 in 20 chance that that's not accurate.
Go with, I love this, there's a 1 in 20 chance that's not accurate. Say that's not accurate using context from the actual experiment. I love that, Brandon, thank you.
There's a 1 in 20 chance that lung function parameters aren't significantly reduced.
Even though they said
That they are.
that they were. That's what I want to, beautiful. When you interpret what a type 1 error is, tell them what the researchers said and tell them how they were in error. I love the 5%, that was a perfect touch. There's a 1 in 20 chance that the researchers, even though the researchers said parameters were down, there's a 1 in 20 chance that they're not down, they just got deviant data. You don't need the deviant data part of that, that makes people freak out a little bit. I've tried that on my neighbors, they don't like it very much. But you can say, a type 1 error, a false positive, you might call it a false positive, they might get what a false positive is. Probably not in the realm of statistics. But a type 1 error simply means the researcher said lung function is down, but it actually isn't. It actually isn't. That's all. Context. Imagine trimming your shrubs next to your neighbor, leave it the beaver moment, explaining this conclusion to them and how they could be wrong. That's how I want you to think in this class. I want to teach you for your neighbors. Teach you so that you can consume the news better. So you can watch the news and go, what's the margin? What's false positive rate? These kinds of questions I want you to ask. Yes? Good? All right, let's call it a day. We'll get into the false negatives tomorrow. That's a little more heavy and a little more ethereal. So we'll get into that tomorrow. Say tomorrow, I mean Thursday. And we'll get the in-class quiz done then too. Got a good one for you guys. Involving red wine and white